Compounds composed of metals and non-metals do not contain molecules. It consists of ions, oppositely charged ions. What are ions? Or we can say oppositely charged particles, positively charged particles as well as negatively charged particles. These are called ions. So what is an ion? Ion is an electrically charged particle which can be negatively charged also, which can be positively charged also. So that on the whole the compound is electrically neutral. Positively charged particle is called cation and negatively charged particle is called anion. Now, if electric current is passed through a compound which is formed by metal and non-metal, it is found that the positively charged particle will get attracted towards negatively charged cathode. That is why positively charged particles are called cations, and negatively charged particle will get attracted towards positively charged electrode which is called anode. That is why negatively charged particles are called anions. That is why this name has been given to positively and negatively charged particles as cation and anion respectively. Now let us discuss some of the ionic compounds and also find out their ratio by mass. But one thing you keep in mind, that the compounds which are made of metals and non-metals do not contain molecules, but they exist as ions of opposite charges. So molecules are present in the case of the compounds formed by the combination of non-metals. Non-metal combines with a non-metal, forms a compound which consists of molecules, which does not consist of charged particles. So this difference you should keep in mind. Now let us see some of the ionic compounds: calcium oxide, magnesium sulfide, sodium chloride. Now you can very well see it is made up of a metal and a non-metal. So identify which one is a metal, which one is a non-metal. Calcium is a metal, oxygen is a non-metal. In magnesium sulfide, magnesium is a metal and sulfur is a non-metal. In sodium chloride, sodium is a metal and chlorine is a non-metal. Now what are the constituting elements in calcium oxide? Calcium and oxygen. So if you know the formula of calcium oxide, you can find out the ratio by mass. If you know the atomic mass of calcium and oxygen, so the ratio by mass, atomic mass of calcium is 40 and that of oxygen is 16. Now find out the ratio. So what will be the ratio? If you divide it by 8, 5 is to 2. So we got the simpler ratio by mass. So ratio by mass is equal to 5 is to 2 between calcium and oxygen. Let us take the second ionic compound, magnesium sulfide, and what are the elements, metal and non-metal present in magnesium sulfide? Magnesium and sulfur. So again we can find out the ratio by mass between magnesium and sulfur. The atomic mass of magnesium is 24 and that of sulfur is 32. So here find out a number by which both can be divisible. So that number will be 2, 4 or 8, 8 also. So if we divide it by 8, we can get the ratio by mass, 3 is to 4. So, magnesium and sulfur are in the ratio of 3:4 by mass in magnesium sulfide. Sodium chloride, you know the formula of sodium chloride? NaCl. Na is sodium metal and chlorine is a non-metal. Now, atomic mass of sodium is 23 and that of chlorine is 35.5. Can we get a simpler ratio from this? Is it divisible by any common number? So, answer is no. So, the ratio between sodium and chlorine is 23:35.5, right. Now, you will think how to learn the atomic masses of so many elements. That also you will learn by practice only, gradually you will learn, and for the time being you can consult the books to see the atomic masses of the various elements to find out the ratio by mass. Now, let us see some of the ions. As I have already told you, the ions are of two types, positively charged ions and negatively charged ions. Now, positively charged ions are formed from the metals. So, metal atoms, they lose electron and form positively charged ions and they are called cations, and negatively charged ions are formed from non-metals and they are called anions. So, let us now see some of the ions made from metals, some of the ions made from non-metals, and see how we can represent them, how we can represent the charge on these ions. Now, you can see these metals: sodium, potassium, silver, copper. Sodium, as you know, the symbol is Na and the ion has a charge, positive charge on it, and it has a +1 charge. So, to indicate +1 charge, we can simply write plus as superscript. So, these four are the examples of the metallic elements which have +1 charge: potassium, K plus, silver, Ag plus, Cu plus. Now, we have written 1 here in the bracket. So, for this means that copper atom has valency 1, because there are some of the metals which have variable valency, and these metals are copper, iron. Copper has two types of atoms with valency 1 also and with valency 2 also, and same way iron also has variable valency of 2 and 3. So, it forms two types of compounds, copper as well as iron. Now, here magnesium, calcium, zinc, iron, copper, all these metals form bivalent ions with +2 charge. Here iron 2 is written, it means it has 2 valency, copper 2, this also 2 valency, it will form a bivalent ion, an ion with 2 positive charges. So, how to write it? So, to represent these ions, first we write the symbol and then 2 plus, which means it has 2 positive charges. 2 plus, 2 plus, and similarly 2 plus. Now, see this aluminium and iron. Here aluminium and iron form the ions with 3 plus charge. So, aluminium 3 plus and iron 3 plus. Now, let us see in this table some non-metallic elements and the ions formed by them, the anions with the negative charge. Hydrogen forms hydrogen ion. Hydrogen is an element which forms both types of ions, positively charged ions as well as negatively charged ions. So, hydrogen forms hydrogen ion with the +1 charge and also hydride ion with -1 charge. Chloride, bromide, iodide, these also form the ions with unit negative charge, that is 1 charge, -1 charge, minus, to indicate -1 charge, there is no need to write 1, only simply write the sign. Oxide and sulphide ions have -2 charge. So, oxide we will write as 2 minus and sulphide 2 minus. Nitride ion has 3 minus charges, 3 negative charges. It is represented by writing the symbol of nitrogen with the 3 minus charge. Now, these negatively charged ions are formed by gaining of electrons. Electrons are gained, so negative charge increases, number of electrons increase, which gives a negative charge to these ions, and these ions, as I have already told you, are called anions, which are negatively charged. Of course, hydrogen is positively charged, it is not anion here. Also, there are ions which are formed by the combination of different atoms, and these are called polyatomic ions, in which the ion has more than one type of atoms, like ammonium ion. Ammonium ion is formed by nitrogen and hydrogen. So, you have to remember the symbols here. Ammonium ion is positively charged, it has +1 charge. So, +1 charge is shown by writing the sign only. Another ion which is polyatomic is hydroxide ion. The symbol of hydroxide ion is OH, and it also has -1 charge. So, -1 charge is written by simply writing the sign. Nitrate ion is a polyatomic ion and its symbol is NO3, and it has also -1 charge. Hydrogen carbonate, it is made up of 3 types of atoms, HCO3, and its charge is -1. So, all these have either +1 charge or -1 charge. Now, this some of the ions with 2 negative charges, like carbonate ion is another polyatomic ion, and its formula is CO3, and it has 2 minus charges. Sulphite ion, its formula is SO3, and its charge is 2 minus. The sulphate ion is written as SO4, and its charge is 2 minus. Phosphate ions, the formula of phosphate is PO4, and its charge is 3 minus. So, these are polyatomic ions. Now, let us discuss about the ionic compounds. Ionic compounds are made up of ions, positively charged ions and negatively charged ions, which are held together by strong electrostatic forces of attraction. Also, I have given you a table in which were written positively charged ions and negatively charged ions, and also polyatomic ions with their charge. Positively charged ions are called cations, and negatively charged ions are called anions. So, let us discuss one of the ionic compound, NaCl. Now, you can see here NaCl does not exist as a NaCl molecule. It exists in the form of positively charged sodium ions and negatively charged chloride ions, and these lines indicate the strong electrostatic forces of attraction between the oppositely charged ions. as I told you that positively charged ions are formed by the loss of electrons. In a neutral atom, the number of electrons and protons are equal. Electrons are negatively charged and protons are positively charged. So, when positive and negative charges are equal, the atom is electrically neutral. But when loss of electron occurs, what happens? Let us see here, in this case, one electron is less. So, because positive charge is more than the negative charge, so there is unit positive charge, +1 charge on sodium ion. Just very briefly I am telling you, in details you will study later on the how cations are formed and how anions are formed. Let us take the example of chlorine atom. How anion is formed, a general idea you should have. In the chlorine atom there are 17 electrons and 17 protons. So, as the positive charge and negative charges are equal, chlorine atom is electrically neutral. Now, when it gains an electron, what happens? Suppose it gains one electron, so number of electrons will become 18 and there is no change in the number of protons. Here you can see negative charge is more by 1 than the positive charge, and so there is unit negative charge on the chloride ions. So, you should know that cations are formed by loss of electrons and anions are formed by gain of electrons. Now, what is the unit of ionic compounds? In the case of the molecular compounds, the unit is a molecule, but here what is the formula unit? We call it formula unit because ion is not a unit. Now, what is formula unit? It is the simplest combination of ions which is electrically neutral. Na plus Cl minus forms a formula unit of NaCl and it is electrically neutral. Now, let us now study how to write a chemical formula. All of you might be knowing what is a chemical formula. A chemical formula represents the composition of a substance with the help of symbols of the atoms which are present in that substance. Chemical formula tells about the kind of atoms present in that substance and also the number of atoms present in that substance. Like this, MgO, NaCl, CuS. So, these formula when we see, we come to know that this substance contains magnesium and oxygen, one atom of magnesium and one atom of oxygen. Now, how to write the name? You have seen that in these metal is written first and the non-metal is written afterwards. So, metal is written on the left hand side and non-metal is written on the right hand side. And how do we name it? We name it as, the name of the metal is written as such, magnesium, and instead of writing oxygen we write oxide, magnesium oxide. Same way here, sodium chloride. Chlorine is not written, chloride is written. And here copper sulfide. CO. Carbon is a non-metal also, and oxygen is also a non-metal. Here also there is a rule, one property is followed. Carbon is less electronegative than oxygen. Electronegativity is the property of an element which has the ability to attract the shared pair of electrons. Details you will learn later on. Carbon is less electronegative than oxygen, so it should be written first on the left hand side and oxygen on the right hand side. Now there is only one oxygen, so how it is written? It has to be written like carbon, mono for one oxygen atom, mono oxide. Now another compound of carbon is CO2. So here also carbon is written as such, and to indicate the number of oxygen atoms, di is written. Di means 2, and for oxygen, oxide is written. Here phosphorus is written as such, phosphorus, and to indicate the number of chlorine atoms, tri is written, tri, and for chlorine is written chloride. Here it is carbon, carbon is written as such. There are 4 atoms of chlorine, so tetra is written, tetra chloride. Here phosphorus. Now there are 5 atoms of chlorine, so for 5 atoms of chlorine the word used is penta, penta chloride. Let us see some more examples of the chemical formula, how to write them, how to read them. Here there is 1 atom of nitrogen and 1 atom of oxygen. We call it as nitric oxide also, and we can also write it as nitrogen, no change in nitrogen, 1 atom of oxygen, so mono oxide. Here this is NO2, another compound formed by nitrogen only. So there are 2 oxygen atoms, it is written as nitrogen dioxide. This is another compound formed by nitrogen. How to read it? N2O is the formula. To indicate the nitrogen atoms, a prefix is written before nitrogen, so it is di-nitrogen, and for 1 oxygen atom, mono oxide. Here it is N2O3. So think over it now. How will you write the formula of N2O3? 2 nitrogen atoms and 3 oxygen atoms. So it is written as dinitrogen trioxide, dinitrogen trioxide. N2O4. Now try to write yourself and also do the practice to how to read the formula and how to write the chemical name. So it will form dinitrogen tetraoxide, dinitrogen tetraoxide. N2O5. How will you write it? Very simple. Di nitrogen, and to indicate 5 oxygen atom, penta oxide. So, like this you can do the practice of writing the formula, and also how to write the name, and now we will discuss how to write the chemical formula. Now, let us learn how to write a chemical formula. First of all, you should know the symbol of the elements from which the compound is made up of, and then you should know the valency. Now, what is valency? Valency is the combining capacity of an element. Now, how to find out valency, that you will study later on in detail. Some of the valencies you can learn. In the case of ionic compounds, you should know about the charge on the ions, on the cations and the anions for writing the chemical formula. So, let us take some of the examples so that you come to know how to write the chemical formula. Now, for writing the chemical formula, first of all, the symbols of the elements are written. So, first of all we write the symbols. Symbol of hydrogen is H and that of chlorine is Cl, and then write the valency. Valency of hydrogen is 1, valency of chlorine is 1. So, this you have to remember. Then what is done? The valencies are crisscrossed like this. This forms the formula H1 Cl1. So, if there is one hydrogen atom, one chlorine atom, there is no need to mention 1, it should be written as HCl. So, HCl is the formula of hydrogen chloride. Hydrogen sulfide. So, here when we write the symbols of hydrogen H and sulfur S, and then write the valency. Valency of hydrogen is 1 and that of sulfur is 2. So, this valencies you will learn by practice. The valencies are then crisscrossed like this. It will go as subscript, and one will go here as subscript for sulfur. So, what do we get? We get H2S1. I have already told you there is no need to write 1. So, the formula will be H2S. You need not to write this, need not to write 1. So, correct formula is H2S. Take another example, carbon and carbon tetrachloride. So, symbol of carbon is C and that of chlorine is Cl. What is the valency of carbon? It is 4 and valency of chlorine is 1. So, 4 will be written as subscript behind Cl. So, what do we get? We get CCl4. We will not write C1Cl4, we will write simply CCl4. Magnesium chloride. It is an ionic compound. In this case also either charge we can take or valency we can take. So, we can take charge also and valency, because charge is also 2 of magnesium and valency is also 2. In the case of chlorine also valency is 1 and charge is -1. Symbol of magnesium we write and that of chlorine, and then let us take charge here is +2 and it is -1. Here again the same rule follows, charges are crisscrossed. So, 2 will go here behind Cl as subscript, and so we get the formula MgCl2. We will not write 1 as I have already told you. Let us discuss some more examples so that you learn better for writing different types of compounds. So more practice you do, more you learn. So you also yourself do a lot of practice by writing the names and then the formula yourself. The symbol of carbon is C, that of oxygen is O. The valency of carbon is 4 and that of oxygen is 2. Valencies are crisscrossed. So what do we get? C2O4. So what do we get? We will not write it as C2O4, we will simplify it because 2 is common. So we will get C1O2, but 1 we do not write, so for formula will be CO2. Sulfur dioxide, symbol of sulfur and oxygen, and then the valency. Valency is 4 and 2. Valencies are crisscrossed. And now think over the formula. It is more or less same as carbon dioxide. So the formula will be S, 2 will go here, S2, 4 will go here, S2O4. S2O4 we do not write, we will simplify it. 2 1s are 2, 2 2s are 4, and so we get S1O2 or SO2. S1 we do not write, S1O2 will not use. Aluminium oxide. Aluminium and oxygen, the charge as well as the valency is 3. Charge is plus 3, valency is also 3. So either charge or valency we can write. If we write charge, we will write plus 3. Charge is minus 2, valency is 2. So if we write charge, we will write minus 2. So it will be crisscrossed. 2 will go here. So what do you write? Al2. 3 will go here as subscript O3. Calcium oxide. Symbol is calcium and oxygen. Here also valency of both calcium and oxygen is 2 and charge of calcium is plus 2 and that of oxygen is minus 2. So whatever you write, and when you crisscross the charges, what do you get? Ca2O2, right? So simplify it and what do you get? CaO. Now I have told you about the polyatomic ions also. So now let us discuss some compounds in which, ionic compounds in which there is a polyatomic ion, like sodium carbonate. So first of all write the symbol of sodium Na and the symbol of carbonate ion CO3. The charge on sodium is plus 1 and on carbonate ion is minus 2. Charges are crisscrossed. Okay. So here it will be 2 behind sodium, and for carbonate ion there is no subscript, it is 1 only, so we do not write 1. So we can write it like this, Na2CO3. Another ionic compound where there is a polyatomic ion is ammonium sulfate. Both the ions are polyatomic. Ammonium ion, you should learn the symbol, the formula of ammonium ion. It is NH4 and sulfate ion is SO4. So what is the charge on ammonium ion? It is plus 1 and on sulfate ion is minus 2. So on crisscrossing, what do you get? 2 will come here behind ammonium ion as subscript. Now how to write it? When we have to write any number after A, polyatomic ion, a bracket has to be used, and then 2 will be written here as subscript. You cannot write without a bracket. And for sulphate there is no subscript, because we have not to mention 1. For sulphate ion there will not be any bracket. Another ionic compound having a polyatomic ion is magnesium bicarbonate. So, first write the symbols and the charge, +2 and -1. Crisscross the charges. What do you get? 1 here. So, 1 you need not to write Mg, but here behind HCO3 bicarbonate ion you have to use a subscript. So, it has to be written in bracket. So, formula will be MgHCO3 whole twice. Sodium hydroxide. The symbol is Na and that of hydroxide is OH, and the charge on sodium is +1 and -1. So, what do you get? 1 is subscript for both the ions. So, we can write it as NaOH. Another compound is calcium hydroxide, Ca and OH. Write the charges +2 and -1. Charges are crisscrossed, and for calcium, because there is subscript only 1, so 1 will not write, but for hydroxide subscript is 2, so 2 will be written outside the bracket, and in the bracket you have to write OH. CaOH whole twice will be the formula of calcium hydroxide. Also, another typical thing I want to tell you, that when we write the formula of water, now you will see that it has not mentioned the names of the elements present in water, and you all know the formula H2O, right? We do not call it dihydrogen monoxide, we call it water only. So, here this is a typical thing. For ammonia also same thing, it is NH3 is the formula and it is named as ammonia. Ammonia also does not tell us about the names of the elements present in ammonia, and also we do not call it as nitrogen trihydride. It is written as NH3 and its name is ammonia. You have studied about the atomic mass. Now, let us study about the molecular mass. What is the difference between the atomic mass and molecular mass? I hope you know. Atomic mass is the mass of an atom and molecular mass is the mass of a molecule. A molecule is formed by the combination of atoms of same element or different elements. So, now let us discuss about the molecular mass. Now, molecular mass also in the same way is the relative mass of molecule of a substance as compared to mass of C12 atom, which is taken equal to 12 units. So, that is also a mass in comparison, and the unit of molecular mass is atomic mass unit or unified mass U, which is nowadays used. But how is molecular mass found? From the formula. Molecular mass is the sum of atomic masses of the atoms present in a molecule, like H2. The mass of one atom of hydrogen is 1, so H2 the mass will be 2 U. O2 is a molecule, so its molecular mass will be 16 into 2, that is 32 U. 16 is the atomic mass of oxygen. Water, So, by adding the atomic masses of hydrogen, 2 atoms of hydrogen and 1 atom of oxygen, we get the molecular mass of water. So, molecular mass of water will be 2 into 1 plus 16, that is 18U. The mass of molecular mass of carbon dioxide, 12 plus 16 into 2, right. So, what do you get? 44U. Molecular mass of methane, now do it yourself, because now you know how to find out the molecular masses. Atomic mass of carbon is 12 and that of hydrogen is 1. So, 4 into 1, 16U. Mass of HNO3, 1 plus. Nitrogen has atomic mass 14 and oxygen 16. So, 3 atoms of oxygen, 16 into 3, that is 48 is equal to 63U. Now, another term is formula unit mass. What is the difference between molecular mass and formula unit mass? Molecular mass is for those substances which exist as molecules, and formula unit mass is for the ionic compounds. Just now I have told you about the formula unit. So, Na2O is simple combination of ions which is electrically neutral. So, Na2O is the formula unit of sodium oxide, and the formula unit mass is obtained by adding the atomic masses of the atoms present in the formula unit. And in the same way, formula unit mass is also the relative mass of formula unit as compared to the mass of C12 atom taken as 12 units. And also I have already told you that 1U is equal to 1 upon 12 of C12 atom, 1 upon 12 of mass of C12 atom, right, and it is the mass in comparison. When we say that molecular mass of water is 18U, what does it mean? It is the mass in comparison. It means a water molecules is 18 times heavier than 1 over 12 of mass of C12 atom. So, this you keep in mind. So, let us find out the formula unit mass. Sodium atomic mass is 23 into 2 plus 16 is equal to 46 plus 16 is equal to right 62U. NaCl 23 plus. Atomic mass of chlorine is 35.5. Now you can add up. What do you get? It will be 58.5. So, first of all you should find out the atomic masses of the elements present in that formula unit. Zinc oxide, you cannot remember, either it will be given in the question or you can find out from the book at present. What is the atomic mass of zinc? It is 65 and that of oxygen is 16. So, add up 81U. Okay. Now, find out what is the atomic mass of calcium and chlorine. Atomic mass of calcium is 40 and that of chlorine is 35.5. So, multiply it by 2 because there are 2 chlorine atoms in the formula unit. So, it will be 40 plus 71, that is 111 U. For this formula unit, the atomic mass of potassium is 39 into 2 plus there is only one carbon atom, its atomic mass is 12, and there are 3 oxygen atoms. Mass of one oxygen atom is 16, so 16 into 3. So let us simplify it. And let us add up. Right. So like this, do the practice of finding out the molecular mass of the simple compounds and formula unit mass of the ionic compounds. Now one more term I would like to discuss with you is the gram atomic mass and gram molecular mass. Now gram atomic mass is the atomic mass expressed in grams. The unit of atomic mass is U and the unit of gram atomic mass is grams. So numerical value is same, only the unit changes. So gram atomic mass say of carbon will be 12 grams. Gram atomic mass of oxygen will be 16 grams. Atomic mass of oxygen is 16 U and gram atomic mass is 16 grams. We will study more about gram atomic mass when we study about the mole concept. Gram molecular mass also is molecular mass expressed in grams. You know the unit of molecular mass is U and unit of gram molecular mass is grams. So here we have seen hydrogen, gram molecular mass is 2 grams, gram molecular mass of carbon dioxide is 44 grams. And for these also NaCl, if we take the gram molecular mass, though it is not a molecule, it will be 58.5 grams. Let us study about another term, mole concept. What is mole concept? Let us first of all consider this chemical equation. 2H2 plus O2 gives 2H2O. What does it tell you when you read this equation? That 2 molecules of hydrogen react with 1 molecule of oxygen and it forms 2 molecules of water. Also it tells you about 4 U of hydrogen react with 32 U of oxygen and forms 36 U of water. Now the question arises, you cannot count the number of molecules because molecules are so small in size, atoms are so small in size, and also you cannot measure this 4U, 32U or 36U. So it was later thought that some unit should be introduced to link the number of atoms with mass, which can be measured. So this term mole was first of all introduced in 1896 by a scientist Wilhelm Ostwald. From a Latin word he took the name moles, which means a heap or pile, and this word mole was accepted in 1967. It is a counting unit, just like when you go to market to buy bananas, if you say you want 1 dozen banana or 1 dozen pencils, what does 1 dozen mean? It means 12. In the same manner, mole is a counting unit. It means when we mention 1 mole, it means it is equal to 6.022 into 10 raised to the power 23 particles. Now, which particles? The particles can be atom, molecules, ions, or electrons, protons, neutrons, and so on. All atomic and subatomic particles can be counted by the unit of mole. Also, another term is molar mass. What is the mass of 1 mole? Mass of 1 mole is called molar mass. And what is molar mass? Molar mass of an element or a compound is equal to its gram atomic mass or gram molecular mass, which we have already discussed. Now, let us also study some more so as to know more about this concept mole. When we say 1 U of hydrogen, what does it mean? 1 U of hydrogen means 1 hydrogen atom. And when you say 1 gram of hydrogen, what does it, how many atoms are these? It means 1 mole of hydrogen atoms, which means how many atoms? 6.022 into 10 to the power 23 hydrogen atoms. Similar is the case here. Now, you can yourself see 16 U of oxygen means what? 1 oxygen atom. And 16 gram of oxygen means 1 mole of oxygen atoms. 1 mole of oxygen atoms, which is again equal to same 6.022 into 10 raised to the power 23 oxygen atoms. Right. Now, if we say 32 U of oxygen molecules, now think over it. 32 U of oxygen gas is equal to 1 oxygen molecule, O2 molecule. And if we say 32 gram of oxygen gas, it means 1 mole of oxygen molecules equal to 6.022 into 10 to the power 23 oxygen molecules will weigh how much? 32 grams. Let us take the example of a compound. 18 U of water means 1 water molecule. And when we talk about 18 grams of water, it means 1 mole of water molecules, which means 6.022 into 10 to the power 23 water molecules. So, mole is a very good unit by which the number of atoms or molecules are connected by the mass of that element or compound in grams. So, if we know the mass of an element or a compound in grams, we can find out how many moles are there or how many atoms or molecules are present in that element or compound. So, that we will discuss right now. Let us discuss some of the sums, how to find out the number of moles if the mass of the substance is given in grams, and some formula which you can use to do these calculations. So, first of all, I want to tell you about this Avogadro number. As I told you, 1 mole is equal to 6.022 into 10 raised to the power 23 particles. this is called Avogadro number and is denoted by the symbol NO. This Avogadro number name was given first of all by an Italian scientist, Amedeo Avogadro. That is why it is called Avogadro number. So whenever you read this name Avogadro number, do not get confused. It is equal to 6.022 into 10 to the power 23 particles. If mass of a substance in grams is given, how to calculate the number of moles from it? For this you can use this formula. Number of moles is equal to mass of a substance in grams upon the molar mass. So if you know the molar mass, you can find out the number of moles, from which you can find out the number of atoms or molecules also. Now some of the sums we can do. 52 grams of He is there. How to find out the number of moles? Now for this you should know about the molar mass of helium. It is equal to 4 grams. So the number of moles is equal to this formula we will use, mass of substance in grams, that is 52 upon the molar mass 4, it is 13 moles are present, 13 moles of helium present in 52 grams of helium. In the second sum, a number is given. We have to find out the number of moles of helium atoms. Now how to find out the number of moles? For this formula will be used, number of moles is equal to number of given particles upon the Avogadro number. 12.044 into 10 to the power 23 upon the Avogadro number is 6.022 into 10 to the power 23. You can see it is just double of this. So when it cancels out, we will get 2 moles. So these particles are equal to 2 moles of helium atom. Now another example we can do, calculate the mass of 0.5 moles of nitrogen gas. So as you know, the molar mass of nitrogen is N2 is 28. 14 is the molar mass of nitrogen atoms. So 14 into 2, 28 grams. So molar mass of N2 is 28 grams. So it is the mass of 1 mole. So mass of 0.5 mole of N2 is equal to 28 into 0.5, it is equal to 14 grams. To find out the mass of 0.5 mole of nitrogen atoms, for this you should know molar mass of N atoms is equal to 14 grams. So mass of 0.5 mole of N atoms. So how will you find out? Now think over it by multiplying 14 with 0.5. So 14.5 is equal to 7 grams, because 14 gram is the mass of 1 mole of nitrogen atoms. Now in this case, number of atoms, nitrogen atoms is given. So first you find out the moles and then find out the mass. Is it okay? So how to find out the number of moles? Formula you have already seen by dividing the number of atoms with the Avogadro number. 3.011 into 10 to the power 23 upon the Avogadro number into 10 to the power 23. What do you get? It will be 1 by 2, this will cancel out. So, how many moles you get? 0.5 mole. So, the mass of molar mass of nitrogen you already know, 14 grams. So, the mass of these particles 0.5 mole is equal to 0.5 into 14, that is 7 grams. And here another question is given, numerical is given, 6.022 into 10 to the power 23 number of N2 molecules. Now, is it not familiar? This is the Avogadro number. So, this number is equal to 1 mole, you already know it. If you divide it by the Avogadro number, you will get 1 mole of nitrogen molecules. So, mass of 6.022 into 10 to the power 23 nitrogen molecules is equal to 1 mole of N2 molecules, and its mass is equal to how much? 28 grams, because 14 grams is the mass of molar mass of nitrogen atoms. So, N2 14 into 2, 28 grams will be the molar mass of N2 molecules. So, like this, try to solve as many numericals as follows. Try to solve as many numericals as possible, so as to learn better about the mole concept. Do a lot of practice. Now you know about the mole concept. Let us revise what is a mole and study the relation between the Avogadro number, the mole, and the mass of the substance. So, in this column is written the Avogadro number, that is 6.022 into 10 to the power 23. In the center is mole, and on the right hand side is the mass in grams. So, 6.022 into 10 to the power 23 atoms of carbon means 1 mole of carbon atoms, and the weight is 12 grams of carbon atoms. Also, 6.022 into 10 to the power 23 atoms of hydrogen means 1 mole of hydrogen atoms which weigh 1 gram of hydrogen. So, 1 gram of hydrogen gas, if it is taken, it will be 1 mole of hydrogen atoms, and it will have 6.022 into 10 to the power 23 atoms of hydrogen. 6.022 into 10 to the power 23 subatomic particles, also equal to 1 mole of particles. Now, what are subatomic particles? These are electrons, protons, neutrons. You will study about this in the next chapter, which means 1 mole of electrons or protons or neutrons, which is equal to relative mass of these particles in grams. You will study in the next chapter that the mass of electron is taken equal to negligible, because it has a very small mass, so it is not considered, whereas the mass of proton and mass of neutron is taken equal to 1 U. It is also the relative mass. So, mass of 1 mole of proton and mass of 1 mole of neutron will be equal to 1 gram. 6.022 into 10 to the power 23 number of molecules is equal to 1 mole of molecules, which is having the mass gram molecular mass, that is molecular mass expressed in grams. So, here instead of molecules, even if we take ions, that will also mean the same. 1 mole of ions equal to the mass of the ions in grams. Now you will think that because the ion is formed from the atom of an element by either the loss of electrons or by the gain of electrons, will the mass of ion change? Will it decrease or increase? The answer is no. The mass of ion in grams or in unified units does not change, because when the electrons are lost or gained, the mass does not change, because mass of electron is negligible. So do not get confused for that. Now, can we find out the mass of any atom in grams by all this data which is known to us, by all this information which we know? The answer is yes or no. Think about it. Can you get? Yes, you can calculate the mass of any atom in grams by this information. So let us do one calculation. You all know that mass of 1 mole of carbon atoms is equal to 12 grams, and it is the mass of 6.022 into 10 raised to the power 23 carbon atoms. So you can calculate the mass of one carbon atom in grams. So mass of one carbon atom is equal to 12 upon 6.022 into 10 to the power 23 grams. So you can calculate and you can get the value in grams. Now another problem let us solve, which has more number of atoms, 100 gram of sodium or 100 gram of iron. So let us first calculate which has more number of sodium ions, or which has more number of or atoms, and more number of iron atoms. Now for this you find out first of all number of sodium atoms. How? You will find by dividing the given mass in grams by the gram atomic mass and then multiplying it by the Avogadro number. So you get the number of sodium atoms, and similarly number of iron atoms is equal to 100 upon 56. 56 is the gram atomic mass of iron into the Avogadro number. So you can complete these calculations yourself, but you can yourself see that sodium atoms will be more in 100 grams of sodium, and iron atoms will be less as compared to sodium atoms in 100 grams of iron. For the ions also there is one problem, so that when you solve the problem of ions you do not get confused. As I have already told you, the mass of ion is the same as the mass of a neutral atom. Find out the number of aluminium ions formed from 54 grams of aluminium. For this you should know the gram atomic mass of aluminium. It is 27 grams. So number of moles of aluminium ion, it has 3 plus charge, so we write it like this, is equal to the given mass upon the gram atomic mass. which is equal to 2 moles. So, number of aluminium ions you can calculate by multiplying the Avogadro number by 2. So, do some more numericals so that your concept of mole becomes more and more clear.